Hello, food enthusiasts, and welcome to this episode of the Future FoodCast. Today, we have a really fun guest you're going to love. He is bringing the sizzle back into supply chain, and we're going to talk all about that. Aidan Mouat is Hazel Technologies. Welcome to the podcast.
Thanks for having me on. Glad to be here.
Yeah, we are so glad to dive in because you're really in a category that I haven't really heard about before. And I'm so excited to share what you're doing at Hazel Technologies with our listeners. So tell us a little bit about what you're doing there.
Yeah, well, so we're a biotechnology company focused on extending the shelf life of perishable food with the ultimate goal of reducing food waste. This has really become the frontier market, increasing the sustainability and economic viability of commercial agriculture. Food waste is an astronomically large problem. We waste about a third of everything that we produce every year. It is a $2.6 trillion problem, as calculated by the FAO. And here in the United States, in particular, in addition to the economic impact and certainly, of course, the calorie impact of losing so much food, we end up wasting about a quarter of our fresh water supply. We waste about 6% of our energy budget, and we burn an extra 300 million gallons of gasoline each year transporting food that will never get eaten. So it has a number of different dimensions impacting almost every sector of the current social fabric. How we look at the problem is one where, what you're really dealing with ultimately is natural pressure on perishable food. So fresh food goes bad, and that's ultimately what drives food waste. There are many different mechanisms for it. We can certainly get into the nitty gritty of it if relevant, but at the end of the day, that's the pressure you're dealing with, is that fresh food goes bad, and that drives food waste. So we wanted to find a way to functionalize parts of the supply chain that traditionally have been culprits in that process. It takes time and energy and cost to transport food from point A to point B, from where it's produced to where it's eaten. We wanted to provide a new layer of chemistry and technology that allowed us to extend shelf life from within those storage and transport sections of the supply chain, so that without having to change the operations of the greater world in the sense of making our customers sort of reconfigure their supply chains, we could start adding value back immediately by protecting food from within existing packaging systems and within existing storage and transport systems. That's fundamentally the types of products that we make.
Aidan, the size of the problem, first of all, that you defined, I don't think most people realize how much food is transported and ends up at a consumer, where a consumer can purchase the food location and then is never used, purchased, consumed. And that is a huge waste issue. I didn't realize the problem was that big. Can you tell me those numbers again you were talking about earlier?
Yeah, absolutely. So we waste about 1.3 billion tons of food a year, which is it's such a big number, it's hard to even reconcile that volume. Like, that number in and of itself, just the waste volume, would be one of the largest industries by volume on the planet if it was being conducted as a trade. And so in 2014, the FAO calculated that it's about a $2.6 trillion loss overall if you factor in not just the value of the food, but also all of the resource intensity that goes into it, the land, the water, the use of chemicals, fertilizers, everything that gets wasted in the process. So it's an enormous economic tag, but we also have a concomitant cost in natural resources. And so I know the US numbers better than I know most of the world numbers, but in the US, we waste about 24% of all of our fresh water in wasted food, and about 6% of our total energy budget in producing that food. We burn about 300 million gallons of gasoline each year transporting food that never gets eaten, and we end up ejecting about 220 million tons of CO2 equivalents into the atmosphere each year as a result. In fact, in the era of climate change, food waste is a massive issue. It contributes about 8 to 10% of our total greenhouse gas bill every year. So if it was a country, food waste would have the carbon footprint of a country. Food waste would be the third largest on the planet behind the US and China. It's one of the single biggest individual contributors to climate change today. It's the size of the entire construction industry and the size of the entire airline industry. So that's when we talk about this scale. I mean, I think it's popular to think about sort of food waste as a diffuse problem, as like something that just happens, right? You threw out a tomato, or something's not looking good at the grocery store, or whatever it is. But if you really dive into it, when you add all of that up, the volume of waste is astronomical relative to the needs of the planet.
Yeah, and thank you for clarifying that and giving us something else to measure it against. I mean, the size of the problem. I think it's really important for our listeners to understand that's one of the motivators for you to tackle this and why you've put so much energy into what you're doing. All right, so talk to us about some of your solution, because you really have a novel idea. You talked about the biochemistry and working with that in our food system. So share with us what you're doing.
Absolutely. So, we look at this, there's a couple of different ways to think about it, but in essence, we wanted to marry the approach of many technologists in attempting to provide additional stack value in terms of like, okay, you have an infrastructure, how many different layers of value can we stack on that infrastructure, right? So we approach it from a biochemistry perspective, which is a bit different than digitization. And the reason I think that's important is you can't really digitize food in a meaningful way. You can certainly increase the efficiency of your logistics. There are strategies, things like first in, first out, FIFO, first in, last out, things of that nature. And certainly there are gains to be had from maximizing and optimizing the logistics piece, which can be done digitally. But food is essential. It's always going to be atoms, right? It can't be bytes. Till we get a Star Trek style teleporter or one of those food synthesizing things, we can't make food appear out of digital art. But we like the idea because I think one thing that's missing in a lot of the technology approaches, particularly ones that need to have positive reduction or a net negative carbon footprint. So I'll use the positive version of that, not the negative version. So a net negative carbon footprint. You have to adhere to the idea that life cycle analysis is really important because all of those carbon inputs have to come from somewhere, they have to go somewhere, and you have to take account for them. Well, if you're building a new system, a new piece of equipment, a new platform, whatever it is, you're spending a lot. You're spending a lot of carbon, you're spending a lot of money, you're spending a lot of energy. We didn't want to go that way. We didn't want people to have to build new platforms or have new fleets of vehicles or do something different with their storage systems because it's a barrier to adoption, but also because when you try to build a new thing in the world today, the carbon costs are much higher than if you try to repurpose an older thing. So we said, instead of going that direction, what if we found out a way to functionalize the environment itself? And the way that we approached that was we said, okay, well, we have this intuition of using materials chemistry in sort of packaging material formats, packaging material inserts to control processes that we refer to as small molecule signaling in biological organs. So anything that's alive, which is perishable foods, will be engaging in sort of chemical and biochemical signal transfer with the atmosphere. You're releasing small chemicals, and by that I mean like ethylene, ethanol, ethyl acetate, things that are like C2, C3 type chemicals, and those in turn trigger certain biological responses. A great example being the ethylene response that most specialty fruits and vegetables has, where in the presence of some amount of gaseous atmospheric ethylene, certain biological processes are accelerated, which then ultimately lead to the food going bad much faster. And so that's a thing that has to be corrected. So we figured out we could manipulate those small molecule signaling processes using very scalable, high throughput, very human and earth friendly categories of material chemistry. And what we did then was integrate that with packaging materials and packaging material inserts that allowed us to just drop the solution directly into existing storage environments at any scale. So we can service any scale from individual clamshells all the way to entire warehouses of for cubic feet, stuff like that. Everything in the world to us is just a differently sized container, and we make a product that fits the size of that container, and we're good to go. But yeah, so that's the strategy. We produce these sachets, pads, papers, integrated materials that our customers put into their existing packaging operations. They don't have to change anything. They get the benefit of this slow release chemistry that's purely atmospheric. So there's no contact, there's no residue. You don't have to come up with a process to dip every single piece of food you're trying to treat. You simply are controlling the atmospheric parameters around that food with the ultimate goal of essentially doubling shelf life. That's the power of the chemistry. So that's how we play.
Genius, really genius, Aidan, because you're hitting some of the key obstacles that would normally stop this from being successful. If I'm a manufacturer or a shipper and I've got to get the food from one place to another, boy, I'm excited about the fact, and as an end consumer, I'm excited about the fact that you figured out how to affect the environmental chemistry without affecting the food chemistry. You're not getting in there. All you're doing is slowing down a reaction in the environment to enable the extension of that shelf life. Now, if we go back to some of those earlier numbers that you were quoting, if you double the shelf life, perishable foods you were talking about, I mean, what kind of numbers I think is astronomical impact that we're having there. And we're not changing our packaging. You're just simply doing some kind of insert, which is a really low barrier to entry for anybody who's looking to adopt this type of, it's not really a technology. It is a technology, the innovation. Let's call it an innovation. Innovation. What do you think? What do you call it?
Funny. You bring up a very interesting point because it's invisible, right? We're doing everything in the atmosphere. All the chemistry is invisible. This is actually a really interesting problem with our customers because farmers are very tangible people, right? They work with physical crop and physical processes. So one of the fun parts of being a post-harvest scientist doing invisible gas chemistry that just makes everything better is having to convince the customer that it's there and that it's actually doing something. So we have certainly there's products and then there's like the technology as you framed it, but like also it's also conceptual in some ways, and that's been a very interesting journey to try to provide a physical representation of this chemical process that literally cannot be seen and is actually quite hard to detect even if you don't have very sophisticated equipment.
Mm-hmm.
But yeah, no, I mean that's glad you phrased it that way. It's a very, very amusing part of our business.
Yeah, but I think, and that's funny that whole concept and the adoption of this process or this packaging material, these inserts, it does take a leap of faith a little bit because you're right, it is unseen. It's not like an end product, that you're.
Well, the good news on that, this is a thing that we actually do spend quite a lot of effort to overcome with our customers, not just to overcome in the sense of skepticism, but actually to provide as part of our services, an understanding of the ROI that we're delivering with this. So like you brought up the question, which is like, okay, if you double shelf life, what's the practical impact of that? What does that mean if you're trying to translate that, say, into waste reduction or things like that? And so we spend a lot of time relating the physical measurements that you can take from the impact of what the technology does. And you can actually scientifically, physically differentiate in fruits and vegetables and various things, a key parameter or two that are impacted by the technology that are related to quality and that therefore lead to higher quality and less rejection, right? So things like penetrometry, which is a way you take a measurement of firmness. We talk about firmness in fruits. You can actually physically measure that. Things like Brix content, the amount of sugar that remains in a piece of fruit or a vegetable, things like that. We can measure those and we have to. We have to do that for the customers. And then what we do is we translate that via various mechanisms based on our understanding of the customer's waste profile, the customer's logistic requirements, and so forth. And we try to come up with an understanding of how much waste do we reduce, but also can we drive prices? Can we help our customer get better margin? Can we help our customer service new markets they haven't been able to service before so they can increase their actual volume output? Things of that nature where suddenly it's not just about, sort of decreasing bottom line or increasing EBITDA by decreasing OPEX costs, in the process. It actually becomes a business driver. It's, hey, more sustainably, I can sell more product at a better price. And so while I'm reducing my carbon footprint, my business is actually accelerating. And that's from a chemical engineering, from an environmental engineering perspective, you have to marry profitability with positive social externality, positive carbon, engineering. The requirement that we have as technologists is to be able to sell sustainability at a profit for ourselves and for our customers. That's a required piece of the business model. And so we have to tell our customers through many, many calculations and models, when you reduce your waste by X% or when you increase your shelf life by Y%, this is the practical economic impact that's having for your business. And we do a lot of that. We spend a lot of time working on it.
Yeah, that whole business case, I can see where that would be really important. Now, talk about because you said if you're able to extend the shelf life, I mean, what about things that are maybe only grown in certain areas of the world, for example? If you're able to extend a shelf life, then I no longer, have a limit on, the miles or what oceans I go across, or if I have to fly it or go by boat. I know those are some of the things that are affected too. Maybe the availability of certain products that right now are probably really expensive to get because you maybe have to fly them. But if they lasted longer, can you address that a little bit?
Yeah, totally. I mean, it's a very important element of our food supply chain. One of the key drivers in why we eat the specific cultivars of crops, for example, that we eat is if they travel well. And I know it's fairly popular for people to think of food miles as a highly negative concept. But just a couple of weeks ago, a study came out, the distance, the food miles of a particular piece of food only contribute about 7% of its total carbon footprint. So it's actually quite irrelevant. And in fact, many, many, many bigger components of the carbon footprint of transport are occurring in that last mile piece. It takes a surprising amount of energy and a surprisingly inefficient infrastructure to do mass distribution of small quantities of food. And that's going to continue to challenge a lot of new agricultural models for many years. I mean, controlled environment agriculture, indoor farming, all those things are going to be very heavily challenged with a carbon footprint that is almost double that of conventional production and conventional travel. So we're not really allergic clear about the fact that I would actually like food that normally would be wasted in a field because there's nowhere to sell it. I would love for that to travel twice as far and not go to waste. That would be a net win for the world. Whether or not people like the food mileage concept or not is kind of irrelevant, frankly. So when we think about it from that perspective, we're all about figuring out how to take crops that would either go to waste or as a result may not even be produced and get them to where they need to go in order to have economic impact. That incentivizes the farmers to grow them. That incentivizes the consumers to eat them because they can have a high quality eating experience. That's how we facilitate the transaction, right? So when I mention all of that, one thing that is, I think, very important about our technology, we kind of talked about the ease of use already. And the idea is we're very well positioned to help very wide number of customers because nobody has to pay $2 million in CapEx to build a piece of equipment to use our technology in the first place. So if you're farming 2 hectares of land or if you're farming 2,000 hectares of land, all you do is buy the sachets, put them in the boxes, you're good to go. You can do whatever you want to. That extreme flexibility and democratic approach to the technology also means that if you have small crop production volumes, like if you're doing an heirloom crop, or if you're trying to get away from monoculture and try to move back to antique varieties, or you're trying to do a new cover crop or whatever it is, but you don't produce enough of it to have a very well-defined supply chain and you're worried about the technology you're going to use to get it to market, here we are. That's exactly what we're here to enable. And so it's not just like, hey, we can sell more tomatoes. It's also, we want to see an increase in biodiversity. We want to see an increase in smallholder farmer production. We want all of those increases to be more sustainable than the food systems of the past. And we want to enable those new business models, those new food types, and those new geographies also to come online and serve the world in the way that they can do if only they have the right shelf life technology. That's what we view our role as.
Yeah, and the ease of adoption, I think, can't be understated because that would be a huge barrier. The cost and the just having to have new processes and just the profit margins are not huge, and but they're not affected as much when you have a really easy, same packaging. You just have an insert. It just, on the surface, it's really exciting. I mean, I'm thrilled with this technology, and I'm excited to get the word out to our listeners, and hopefully some of the growers, as you get to be a household name, hopefully, and can impact across the world. It just seems like, because you're addressing a lot of the issues that are being talked about right now, and sustainability is one of your key focuses and requirement for you to have a viable product. And that's, you have such a great focus in a lot of different areas.
Yeah, it's a very interesting business, not just not to talk about the chemistry, but the business model itself. I think I hesitate to say we're the first or the only in the world, but we're certainly one of the only examples, if there are other examples, of a company that is selling sustainability. And that is fundamentally our product. It's not that we sell another product with a sustainable element. We are literally profiting from the sale of increasing sustainability in other people's systems. And it's a business model that I know for sure the venture capital community, the investment community, has been lusting after for, probably since the clean tech investment boom in 2012 at the latest. And I'm sure it started before that even. And a lot of these conversations, I think, in the last 10 years have really, really gone, much more public, much more eyeballs on it, more conversation volume about it. Everybody's talking about it. I just did a review article of the food waste technology space, and all of the landmark studies on food waste, scaling food waste, evaluation of different solutions. So they've all been published in the last 10 years. There's thousands of them. So the conversation is very much coming to the forefront, but I think not a lot of businesses are incorporating ESG into their existing business model. How do you sell a better egg? How do you make a better widget? Whatever it is. But I am not aware of another, prominent market example of a company that just sells sustainability, and that's what we do.
Yeah, and as a founder and CEO, I'm sure you would know about other companies that were right in your space. So I really do think you're
I don't mean, by the way, I don't mean to like detract from other people in their business models. And there are certainly other companies that are developing technologies and markets to reduce food waste, but they're generally doing it. It's more of a roundabout, like, hey, I'm going to do a coating, right? Well, that means what I'm really selling is a machine that does it. I'm not actually selling the waste reduction piece. I'm selling a piece of the supply chain, which there's a room out there for. I'm not knocking it. That's just what that is, versus us where we're going, no. We're not trying to sell you anything other than the direct impact of the technology that we put into your hands.
Well, and on the food waste side of things, there's, I think you mentioned before, like a paradox between, how do you measure the waste that never really happened? Like if you're enabling the perishable foods to not perish and be used, then there's no food waste to measure. But what do you compare to, like what used to happen? Like how do you?
Yeah, it's called the prevention paradox. It's very challenging. Yeah.
Thanks for giving me the right name for.
Yeah, I'll send you a paper about it. Very, very fun discussion. But the prevention paradox essentially says if you prevent something from happening, you can't measure it happen. And in that scenario, it becomes very difficult to understand exactly what is and is not impactful, because you can't live in parallel universes where you did it and didn't do it and measure the actual. This is actually a huge challenge in supply chains in general, because if you're trying to move a technology that has a statistical impact across a big volume of food, you can't replicate that unless you're doing it at the scale of that volume of food. And you can't do like a 1 billion ton test every other year to see if it's working. You know what I mean? So it's a pretty challenging question ultimately. And there's a lot of different pieces to it. One that I think is particularly interesting, and this is a role that I think it is a conceptual role that I think Hazel is starting to play and will play more as we increase our presence and therefore increase the volume of commercial activity that we're engaging in. It's quite difficult for any supply chain business to talk about waste reduction. And the reason is that if I'm a grocery store, I do a new thing in 2022, I come out and I go, hey guys, we reduced our waste by 8% across, all of our supply chains. What I'm really saying is, for the last 40 years, we've been wasting 8% more than we did this year. And that's a black eye. It's a PR black eye. Nobody wants to get involved in that conversation. People don't want to tattle it. This is another big problem that we have in the food waste space, is getting accurate data that isn't biased and that isn't, underreported. And right now, all the papers being published in the field are saying, hey guys, we're underreporting all this stuff. So all the numbers I gave you, you could probably multiply them by 20, 30 more percent, and that might be more accurate. We don't even know. We don't even know the answer to that question. But one thing that we can do is we can work with the system. We can work with all of the different pieces of the system, the retailers and suppliers and all this stuff. We can take the measurements that we take and we can file our own sustainability and say, okay, we deployed this much technology across this much of the food chain. We treated this year, we're going to treat 5.7 billion pounds of food. We expect to save about 460 million pounds. We don't have to name names. We don't have to list who did what, where that came from, but we can talk about regions. We can talk about crop types. We can talk about all this stuff. So we can actually aggregate the efficiency data of increasing the sustainability of these multiplayer complex parts of the food supply chain without tattling on it. And instead it becomes a net positive, because when we issue a sustainability report and it says, hey, Hazel's doing fantastic stuff, like we're the right company for the world. If you're Costco or if you're Kroger or if you're Andy Boy or whoever you're partnering with us, you get to put your name on that and say, we're working with Hazel, we're good for the world as a result. And you don't have to tattle on yourself. So having that like arbitrage, being an arbiter of data side of the food waste equation is going to become a very important role, given that right now nobody is filling it. And as a result, our understanding of waste and therefore understanding of how we reduce waste is limited. And so we look forward to actually being that company.
Yeah. And that's very exciting that you're kind of flipping the model a little bit, rather than looking at the negative and having them have to admit a reduction, which means we've been doing it wrong up till now. And now we're trying to recover. You're trying to make that a more positive, so people will step into that space and own it. And by partnering with you, that's a whole positive, that they're affecting change in that area. And because our food supply, I mean, we're kind of out of land, according to some sources, at usable land, and trying to meet our future needs for food. And so this technology is really important for us to be able to sustain and be a good steward of the resources that we have moving forward. And
yeah, that's the, I mean, you know, it's interesting because you mentioned from a chemical engineering perspective, the best thing you can do is monetize waste. Meaning, like, if I have a process and my process, there's always this joke about the Wacker oxidation. There's a process which you use to create carbonyl species using a sacrificial copper chloride catalyst. And when the Wacker oxidation process was first commercialized, you essentially have to use stoichiometric amounts of copper chloride. For every molecule of acetone you produce, you're producing a molecule of copper 2 chloride that has to be reduced copper 1 chloride that has to be oxidized again in order to use it again. So for a long time, people would joke that when you do a Wacker oxidation, the product of that chemistry is just copper 1 chloride. You're not actually making anything except copper 1 chloride. Whatever your organic chemistry is, doesn't really matter. And the point of that is that when you have any process, if you're wasting metals, wasting pieces of carbon, whatever it is, that's always dollars. I mean, that's carbon is cash ultimately. And so if you're wasting those carbon units, then you're wasting cash in your process. Instead, if you can find a market to put that, create a positive unit economic externality, that cash float is actually what makes a lot of industrial chemistry processes profitable. It's not the primary product itself, it's the sum of all the transformation steps put together. When we think about food waste, which is inherently sort of, the connotation of that conversation is negative, food waste is negative, we see a lot of different things in there. One thing that we see is that if you can profit from the reduction of waste, or at least you can make the reduction of waste a cost lower moment. You don't have to have it be such a cost driver on the balance sheet. But if we can also figure out a way to do more business or better business by driving that waste down, then that creates the positive externality that we're really looking for, and makes it easy to sell the technology, because again, now it becomes a value creator, not just something that lowers. I think it's a very important philosophy. We essentially have to be closed loop, and we have to be closed loop on the economic principle as well as the physical materials that are involved in the process.
Yeah. Well, you have brought up some fascinating things for our audience to think about today, and from a different perspective, and talking about the biochemistry and we did in the opening. I mean, we laughed about it, but making supply chain, putting the sizzle back in supply chain, and just we really do need to talk about it.
Sure.
Out of all that we've covered, is there anything else that you'd like to share with our audience before we go, Aidan?
Yeah, I mean, my messaging has always been chemistry in food already exists, and that's a known. And not only that, we're not going to feed the world at our current population level, but certainly not at the planned 10 billion people over the next 30 years. We're not going to feed the world without agricultural chemistry. That's the way that we got to where we are today, and we got to take care of these people. So that's the way that we're going to keep going in the future. So there are many cool solutions that are all over the world. Everything from controlled environment agriculture being a very interesting example, where unfortunately it's an industry not quite mature, but at the same time, I like things that tend to diffuse production into a larger area of the world, because when we hyper concentrate agricultural production in key areas, it causes a tremendous number of problems. Just look at California, a lot of issues, right? So environmentally, it's better the more you can spread that stuff out. Those are cool. There's cool stuff happening, and I don't mean to steal anybody's punchline on any of that stuff, but that doesn't represent the majority of what people eat on the planet. So 84% of agricultural production is conventional, not organic. It is highly concentrated in key agricultural areas. And the number one output of the world in feeding human beings right now is nitrogen fertilizer. Go ask any farmer right now what's happening to fertilizer prices, and you'll find out exactly how fundamental fertilizer is to our continued existence. So we know that chemistry is part of that. We're not ashamed of it. We think there's ways to do it better, cleaner, safer, both environmentally and from a human health and safety perspective. There are certainly reasons to be skeptical of who's doing what to your food, but that's the role that we want to play specifically, is to be good stewards and protect the supply chain through chemistry in a way that inspires and maintains consumer confidence and safety. And that's the position that we want to take in the market, is to be very proud of the chemistry that we do, and to give people confidence in their food system again, because they can have confidence in us and what we're doing to help them. So that's I think that's I like to bring the positive note back to the idea of doing biochemistry around food. I think that's an important piece of the conversation.
Well, Aidan, thank you so much for bringing your innovation in that chemistry space to our audience and to the other people in the world that are working with our food. I think it's just exciting. Thank you so much for being with us today.
Yeah, thanks for having me. Thanks for the interest. And it's been a lovely conversation.
Thanks for listening to Future FoodCast. Future FoodCast is powered by Farm to Plate, the leading food blockchain platform. Subscribe on YouTube or wherever you listen to podcasts to stay up to date with the very latest innovations in the food industry.